Hello everyone, I am Merlin Subba, Assistant Professor Grade 1, Triple Department, Panimala Engineering College. I am going to give the video lecture on complete transformer active parts. Transformer. It is a static electrical machine which transfers the electrical energy from one alternating circuit to the other alternating circuit without changing the frequency, but voltage and current level can be changed. I said this is a static device since it has no rotating parts. But in motor and generators, there is a rotating parts, so losses will be high in motor and generator. But in transformers, due to the absence of rotating parts, losses will be very less. So efficiency will be very high. Just imagine the transmission of power without the transformer. That is not possible. Reason is, in generating stations, voltage will be generated in low level only due to mechanical and electrical reasons in motor and generators. So, have to go for the step of transformer before transmitting the voltage through the transmission line. What's the function of the step up transformer is? It receives the low voltage from the generating stations and will convert that into a high voltage AC supply for further transmission through the transmission line. Why we need to increase the voltage level is, in transmission line there is a voltage drop. So to compensate the voltage drop, immediately after generating the voltage in generator stations, we should be step upped. Next, it is transmitted to the transmission line. Then at the receiving end, we want the voltage in low level range only. So again, you have to go for the step down transformer there. What's the function of the step down transformer is? It receives the high voltage from the transmission line and it will convert that into a required low voltage level at the secondary side. After that, it will be distributed to the power consumers. Since we need the voltage in only low voltage, so for around 400 volt if it's a 3 phase and 230 volt of single phase. We'll see about the main parts of the transformer, that are core and windings. Before going to the main parts, we should know about the working principle of the transformer. The principle is mutual induction between the two electrical circuits linked by the common magnetic flux. That's a mutual induction principle. Its simplest form, it consists of two inductive coils which are electrically separated but magnetically linked through a path of rho reluctance. So in this diagram, you can see that the blue wires indicates the primary winding and red wires indicates the secondary winding. But there is no electrical contact between these two windings that are electrically separated. But that two are magnetically coupled through the iron core. So the green lines indicate the magnetic flux induced due to the supply given to the primary winding. The two coils possess high mutual inductance. If one coil is connected to a source of alternating voltage, an alternating flux is set up in the laminated core, most of which is linked with the other coil, in which it produces mutually induced EMF according to the Faraday's law of electromagnetic induction. If the second coil circuit is closed, the current flows in it. So electrical energy is transferred from first coil to the second coil. Next, we'll see the main parts one by one. First, we'll see about the core. Yoke. It's made up of silicon steel laminations. Its function is to carry the flux, providing low reluctance path to the magnetic flux from primary to secondary winding, that is for mutual induction. Usually it is of square or rectangular in shape. It has two parts, limb and yoke. Limb is the vertical portion of the core. It carries the windings. Yoke is top and bottom horizontal portions of the core. It provides magnetic path for the flux produced by windings. As I said earlier, the core is made up of silicon steel laminations. Why we need this laminations and what is lamination? Laminations means it's made up of insulated layers of that particular material, iron or steel. Why we need this laminations is the laminations breaks the path for the eddy currents. This prevents the flow of eddy current through the core and reduces the eddy current loss. Then we should know the eddy current loss. What is eddy current loss and how we can reduce eddy current loss by laminating the core. Thus, in transformers, we supply alternating current in the primary. This alternating current produces alternating magnetic flux in the core. And as this flux links with the secondary winding, there will be induced EMF in the secondary. From primary, induced EMF in the secondary, resulting current to flow through the load if it is connected in the secondary side. But some of the alternative flux from primary to secondary of the transformer may also link other conducting part instead of linking with the secondary winding, other conducting path like steel or iron core of the transformer. That fluxes are called as a leakage flux. Alternative flux links with these parts of the transformer. Due to the leakage flux, there would be a locally induced EMF in the same winding itself. So due to this EMF, there would be a current circulated locally at that parts of the transformer. These circulating current never gives any output, but that will be dissipated as heat. This type of loss is called eddy current loss. Actually, this depends upon the thickness of laminations. The thickness of laminations should be from 0.3 mm to 0.5 mm. Reason is eddy current loss is proportional to square of the thickness. If thickness is small, eddy current loss is small. But if thickness is small, that will be a mechanically weak. So we have to select the thickness in such a way that that should vary from 0.3 mm to the 0.5 mm for the proper mutual induction. Windings. Primary and secondary winding should be very close to each other to have mutual induction. There are two types of windings, cylindrical and sandwich type. Cylindrical coils used in core type of transformers. These windings are mechanically strong. In this, how the windings are arranged is, low voltage winding is placed nearer to the core for easy insulation from core and high voltage winding is placed after it. Both the windings are same limb to reduce the leakage flux. In sandwich type, each high voltage portions lies between two low voltage portions to reduce the leakage flux. Sandwich type is used in shell type of transformers. All the parts are insulated from each other by the paper. That is, paper acts as insulator between the low voltage and high voltage windings. Top and bottom coils are always low voltage windings for proper insulation. If subdivisions is higher, smaller is the reactance. Subdivisions in the sense is low voltage section, high voltage sections like that. The subdivision system increases means reactance reduces. Reactance is the resistance to oppose the passing of the flux, that is termed as a reactance. So subdivisions increases means this reactance is reduces. Based on the core construction, transformers are classified into core type transformer and shell type of transformer. First, we'll see about the core type of transformer, both in single phase and three phase. In core type of transformer, half of the primary winding and half of the secondary winding are placed around each limb. So this reduces the leakage flux. Usual practice is low voltage winding is below the high voltage winding for mechanical reasons, and this has single magnetic circuit and core is of rectangular shape always, and winding encircles the core. That is, core is surrounded by the winding. So due to that, natural cooling is effective. And type of winding here is of cylindrical type that already I explained. Next one is the shell type. It has double magnetic circuits and it has three limbs. Both the windings, that is primary winding and secondary winding, are on the central limb only. And in this case, core encircles the winding. That is, core surrounds the winding. Central limb we have the winding and full core surrounds this winding in this case. So natural coring is not possible. Reason already explained that windings are surrounded by the core. And this type of core is used for high voltage transformers. And windings types, if you see, means in shell type it is of sandwich type. Sandwich type already explained, that is between the two low voltage winding, high voltage winding is inserted. This windings, either it is a sandwich type or cylindrical types, it's made up of a copper only. Reason is copper has high conductivity and easily we can bend for winding, and this minimizes the losses. Also, copper requirement can be reduced compared to other materials. About the insulating materials. Uh, Insulating materials must in transformers. That is, once the transformer starts working, the windings and the coil are getting heated. So to avoid this heating effect, some insulating materials are used, that are paper, brushboard, transformer oil, bakelite, fiberglass materials. These are act as a insulating material. Between the primary as well as secondary winding also we will be having a insulating material as a paper, and similarly between the transformer tank and winding also we will be having a insulating materials. The next major topic, that is assemblies of the transformer. First we will discuss about the main points. Now we have to go for the assemblies of the transformer. These are the protective things for the better functioning of the transformer, that are conservator, buck slave, breather, oil level indicator, temperature indicator, cooling arrangement, bushing and transformer tanks. These are must for the proper functioning of the transformer, high voltage transformer. It consists of main parts like winding and core and all the accessories like conservator, oil level gauge, connecting valve, focus relay, breather, thermometer, pressure lift device, cooling arrangement, and the protective tank, everything. Next we see about when the transformer starts working, core and winding gets heated. The time the transformer oil, that is usually used as a cooling medium. Most of the transformers is heated. So to avoid that, you have to go for the various techniques. But in generators and motors, rotating part itself acts as a fan and circulating the air and carry out the heat. However, a transformer has no rotating parts. In small transformers below 50 kVA, natural air cooling is employed. That is, heat produced is carried away by the surrounding air. But in medium size power or distribution transformers, hold by housing them in tanks filled with the oil, that is transformer oil. And that transformer oil serves a double purpose.
One is carrying the heat away from the windings to the surface of the tank, and other is insulating the primary from the secondary winding. These two are the um, advantage of using a transformer oil as a cooling medium. And then for large transformers, external radiators, you can see in the diagram, added to increase the cooling surface of the oil-filled tank. Oil transformer oil is used for the cooling purpose. In addition to that, external radiators are used. The oil circulates around the transformer and moves through the radiators where the heat is released to the surrounding air. Sometimes cooling fan blow air over the radiators to accelerate the cooling process. Conservator. Conservator is a airtight drum mounted on the top of the tank. As I said earlier, when the transformer starts working, there will be a loss in core as well as in the winding. Due to that, temperature of the transformer oil increases. So what's the role of this conservator is it maintains a fixed head of oil in the tank for all operating conditions of the transformer. When oil gets heated, it expands and enters the conservator from the tank and forces some air out of the conservator. Since conservator partially filled with the oil, when the oil contracts, at that time some oil enters the tank from the conservator and the air enters the conservator from the atmosphere. This is the breather. It is used to prevent the temperature oil from absorbing the moisture. That is another when the temperature and the cools at that time air is taken into the conservator from the atmospheric air. At that time, if the moisture content the air mixed with the transformer oil, it will contaminate the transformer oil. So to prevent that, we have to go for this breather arrangement. This breather consists of silica gel. The silica gel absorbs the moisture content in the atmospheric air. That you can see in the diagram over the conservator, the breather will be fixed. Will be the bucket slave. This is a protective device used for protecting against all kinds of faults. Actually, this is a gas activated relay installed in the oil immersed transformers mostly, and it will give an alarm in case of faults in the transformer. It also disconnect the transformer in severe internal faults. How this Cooper's level work means that is depends upon the gas formation inside the transformer mm, tank. When the gas is formed, when the temperature increases, transformer oil decomposes into the gases formed. When the decomposition into the gas will be slow rate, at that time the float fixed at the top of the chamber activated and that will be tilt due to the mercury switch will be activated, that will be connected to the alarm. Now the alarm starts ringing. When this decompression will be in a faster rate, at that time we need an immediate action, that is to at the lower part plug it is activated and that is also fixed with the mercury switch that getting closed and immediately trip the circuit and protect the entire transformer.
Explosion vendors usually used to prevent the damage of the transformer tank by releasing any excessive pressure generated inside the transformer. Actually, this is a bent pipe with thin aluminum diaphragms at both the ends, that is at the top and bottoms, and the diaphragms breaks and release the rapid pressure from the tank, thus saving the tank from bursting. Otherwise, severe damage occurs. A wire mesh is at lower end of the diaphragm to prevent pieces of the rooted diaphragm from entering the tank. And similarly, a wire mesh at upper end is used to prevent mechanical damage to the upper diaphragms. And you can notice this explosion when that is fixed above the level of the conservation tank in this diagram. Transformer tank is the outer cover to provide a protection to the core, winding and other internal parts including a transformer oil. It also provides a rugged, that is strong support to the fittings as well as to the accessories. That is the entire thing fixed to this transformer tank only. And tanks are made up of thin sheet steel. The next we'll see about the temperature indicators. There are two temperature indicators are usually used in transformers, that is WTI and OTI. WTI is winding temperature indicator and OTI is oil temperature indicators. And we know that once the transformer starts working, transformer winding as well as transformer oil getting heated. So each and every time we should monitor the temperature of the transformer oil temperature level as well as for the winding temperature, since these two are the component that getting heated immediately.
It's monitored with the oil level indicator. And we already said oil acts as cooling as well as this acts as the insulator between the primary winding and secondary winding and between the core also. So oil should be maintained always from the transformer. And this oil level indicator will be fixed with the alarm circuit. So if the oil is empty at that time, switch closes and activate alarm.
Bushings. It is a structure carrying a conductor to pass safely. And also it is used to bring the low and high voltage lead out of the transformer tank to make connections between transformer and generator or to the transmission lines. We know that transformer has two winding, primary and secondary. Primary is connected to the supply. How to give the supply, that is also given through this bushing arrangement, that is lead connected to this bushings, and output is taken from the secondary side, that wires is also connected through this bushing arrangement. That you can see in the diagram, wires are connected at the tip of the bushing arrangement.